another interesting lesson. We are talking about physical equilibria, and in today's lesson we shall talk about solvent extraction. In the previous lesson, if I'm to take you back previously, we talked about the applications of solvent of partition law. I hope we all know how to determine the partition coefficient Kd of all different solutes and different solvents. We can all determine. Now we are going to see how can we use that. How can we apply that to solve some chemistry puzzles? So one of the applications we shall find the solvent extraction, and we are going to see what it is. We shall see how we can use the partition law to determine the formula of the complex that is formed, and finally chromatography. So this is where we stopped in our previous lesson. So let's see how we can use our partition law to determine to see how much of a solvent can be extracted. And we all know how to determine the Kd. That's an assumption. If you don't know, then you will go back and watch the videos and get to the bottom of Kd. Then you come back and do solvent extraction. Now with solvent extraction, here it's a technique that is used to gradually isolate a solute from one solvent. That is the basic idea. It's a technique that we use to gradually isolate a solvent, a solute, from one solvent by another solvent, by the way. For example, assuming you want to study. Okay, you are okay. Let me first give you what solvent extraction is before I give you that illustration. So you have solvent, okay? You have your solute that is dissolved in one solvent or in solvent A. So what we do, we get another solvent. The two solvents must obviously be immiscible with each other so that you can clearly separate them. But the solute must dissolve more in the solvent that you are going to use it to extract it. So what you do, you get the other solvent that has high affinity for the solute here. You shake strongly, you strongly shake. Now when you shake, since the solute A dissolves more in solvent B, this is maybe solvent C, the solvent B will extract our solute A, okay, and dissolves more of A into B. So that when you come and run off the layer of C, maybe you would have more of A in solvent B and little A in solvent C. So basically that's the overview of solvent extraction. So it's a technique that is used gradually to isolate a solute from a less soluble solvent by another solvent in which the solute is more soluble, provided the two solvents are immiscible with each other, and the solute can dissolve in each of the solvents. Okay? Yes. So it is This technique is used frequently in industries, or almost industries, in biology laboratories. For example, you want to study a certain chemical, you want to identify, you want to study the concentration of a given chemical. Maybe you want to study aflatoxins. I didn't want to use that word, but let me say it. In a given food value, in a given food. So you crush the food and make a solution, and then you get another solvent where that chemical can dissolve more. And then but the two must be miscible. And then you mix, you shake, so that the aflatoxins of yours can dissolve in this solvent. Okay? Can dissolve in this solvent. And then after dissolving in this solvent, there it becomes easy to isolate your aflatoxins. Even in forensics, they can use solvent extraction. In the hospitals, the same thing. You want to study certain microbe, certain toxin. So this solvent extraction is really used frequently. The two solvents must be immiscible with each other, if you know that. And the solute must be soluble, must dissolve more in this second solvent that you are using than the solvent where it is dissolved. So if you understand those few concepts, then you know what solvent extraction is. So process can be performed at once. Yes, you can. Maybe if you have 50 centimeters cubed, okay, you have 50 centimeters cubed of the mixture of your solvent and the solution, and you mix, okay, you mix it with another 50 centimeters cubed, and you stop there, okay. Or you have 20, you mix it with 20 and you stop there. So we can use the whole of it, okay. Somebody requested to join, so I had to admit. So like I said, you can use, maybe you have 50 centimeters cubed, and you can use the whole of the 50 centimeters cubed of the other solvent where it is more soluble to isolate the solute. Or alternatively, you can use portions. Okay? You can use portions, successful portions. Like instead of using the whole 50, you divide this 50 into portions of 10 centimeters cubed, or portions of 25 centimeters cubed. Okay? So you get the 10, you get the 50, you pour there 10, you shake, and then you attain the equilibrium, you isolate, and you isolate your 10. The 10 extracts some. Then the other new mixture, you get another 10, you pour, you shake, serious shaking. You attain the equilibrium, you keep, then you isolate, you keep your other 10. And you do so successfully or successively. I think that's the correct word. Or you can use 25. You just divide this into two portions of 25, 25, and you mix. You pour the 25, okay? You shake, you attain an equilibrium, you leave it to settle, you attain an equilibrium, you isolate. You have your 25 together with the dissolved solute. Then you add the remaining mixture here, you add also the other 25. Okay, you add the other 25, you shake again, and you isolate the mixture. Okay, and together with your solvent that you are using to extract, so that you have two portions of 25, 25. Now the question is, in each of these ones, where do you expect to isolate more of the solute when you have used one large volume, like the whole 50, to isolate, or sorry, to extract, or where you have used the portions of 25, 25 each? Think about it. You can drop the answers in the chat box. Okay, so where do you expect to isolate, to extract a reasonable amount of the solvent? Okay, yes. Now I know you are thinking about something, but your thinking should be backed up with some science. So let's do some few examples, okay, to see what solvent extraction is. To see, I'm going to do one example, you do another. You know, that's how we've been doing it. But for those who will be watching a video, by the way, if I say example, you pause the video, okay, you do if you can, and then after you click and continue. So basically that's what solvent extraction, that's the idea of solvent extraction is. Let's do some examples and appreciate and see if what you thought about was correct. Let me check your chat box. You never know, you dropped some answers.